So here's what we're talking about here. We're talking about restrictions. Now, functions are all about inputs versus what? Outputs. So you take a function, you put something in, and you get something back out. So let's look at this function. F of x equals 2x plus 3. And what I'd like you to do is I'd like you to think of a number that if I plug it in for x, I will not get an output. Okay, so let me show you what I mean. If I plug 3 in for x, right, I'd have 2 times 3 plus 3, which is 6 plus 3, which is what? 9. So my input was 3, and my output is what? 9. So in this case, I had an input and then I had an output, right? Now, on every function, you can plug anything you want in. You could plug smiley face in. You could put couch in. The problem is, if I plug smiley face in, I don't get an out, right? So what I want to know from you is, can you think of a number that if I put that number in, I won't get an output? Pause the video and think to yourself if there's a number that you can put in that you can't get an output. And so you should be a little confused because there's not one. I can plug any number in for x that I want, and I'm going to get an output, right? But now, not every function's that way, particularly two specific functions. What I need you to think of, is there ever a time in your math career where you plug something in the calculator and it said out to you, error? Okay, so when was that? Good. So if you dividing something by 0 in the calculator will give you a what? An error. It's because we know we can't divide by 0, right? So that's one of our restrictions. Okay, we can't divide by 0. So that's one of our restrictions. Can you think of another time where you've plugged something in the calculator and when you plugged it in, it gave you undefined or error? Say it again. Yeah, the other restriction is if you try to take the square root of a what? A negative number. Okay, so in algebra, those are our two main restrictions. You cannot divide by 0, and you cannot take the square root of a what? Negative. So now let's apply it to a real problem. Okay, look at this function right here. Y equals 1 divided by x plus 1. Now, I don't want you to think so much about what you can put in for x. I want you to think about what you cannot put in for x. Tell me a number that if you put that number in for x, you won't get an output. -1. Yeah, so let's say I put -1 in for x. I say y equals 1 over -1 plus 1. What is -1 plus 1?
0.
Okay, so y'all do in your calculator for me. 1 divided by 0 and tell me what you get. And so if I do 1 divided by 0, what do I get?
A question mark.
A question mark on your iPad. Most calculators will say undefined, error. And your error code will say something like you can't divide by 0, right? And so when my input is -1, my output does not exist, right? And so here's the question then. I need you to help me tell the domain. Okay, domain of a function is basically saying what numbers. There's two ways to think of domain. You could either say in your domain, what numbers can I go ahead and plug in for x? Or you could express your domain by telling me what numbers I can't put in for x, right? So let's think this through. Let's do it in terms of cannot put in for x. So tell me, what number can I not put in for x? -1. So how do we do that in math? See, mathematicians are lazy. They don't want to write x and then the word cannot be -1. So how do we express that in math? X, yeah, an equal sign with a slash through it. X cannot equal -1. Okay? Now, you just told me what it couldn't be, but we know that it can't be -1, but it could be any other number other than -1, right? Okay? And so what I want to say is, I want to say all real numbers. So right here I'm saying the domain is all real numbers except for x cannot equal -1. You see that? So I'm saying I can plug any number in for x. This R with 2 lines going down, that means real numbers. Say real numbers. So I'm saying all real numbers can be plugged in except for x cannot be what? -1. So let's test one. Pick me a number that's not -1.
5.
Okay, so let's plug 5 in our function. Y equals 1 over 5 plus 1, which is 1 over 6, which is a number, isn't it? So when my input was 5, my output is 1/6, right? We're saying the only time we won't get an output is when we plug -1 in. Okay, so why don't we look at this pink function here, y equals 3 divided by x minus 2. And what I want to know is, I want to know what's the domain. Okay, and when I ask you the domain, I'm saying, tell me all the numbers I can plug in and tell me the ones I can't plug in. So what is the only number as I look at that I can't plug in? 2. So I'm saying if I plug a 2 right here, then I'll get 3 divided by 2 minus 2, which is 3 divided by 0, which is undefined, right? So I'm saying I can plug in all real numbers except for x cannot equal what? 2. And so there's your domain right there. There's your domain right there. Domain means what numbers can I be plugged in for x. Okay, so that was dealing with one of our restrictions, right? So we dealt with a 0 under the radical, in the denominator. But let's go over here and look at this function. F of x equals the square root of x minus 4. And what I want you to think is, what is a number I could plug in for x that would cause me problems, right? Let's say I put, 9 in for x. Let's say I plug 9 in for x. So I'd have f of x equals the square root of 9 minus 4. Well, 9 minus 4 is what? 5. And the square root of 5, if you type it in your calculator, it's going to give you like 2 point something, right? What is it? 2.23. So our input was 9, and we had a real output, 2.23, right? I want you to think of what is a number I could put in for x that would give me no solution or an error.
3.
Well, so Gracie said 3. Let's say I put 3 in. What is 3 minus 4? -1. And what is the square root of -1? In other words, what is the square root of -1? It's undefined. It doesn't exist, right? You can't take the square root of a what? Negative. So here's what I need to know. I need you to express to me all the values of the domain. Now, in this case, the values of the domain are going to be more than just one number, right? There's a lot of numbers that could make it. Let's say I plug 0 in. What is 0 minus 4? So now I'm taking the square root of -4, aren't I? I can't take the square root of a negative, can I? So I need you to tell me, think to yourself, what are the values that will give me a negative under that radical? Right? Somebody just said, well, 3 to infinity or negative infinity. But the problem is, what is the square root of 4 minus 4? It's 0, right? So I can plug 4 into the function. So 4 must be the starting point of my domain, right? Now, can I plug numbers bigger than 4 in? Like 5? Could I plug 5 in? What's 5 minus 4? 1. But could I plug numbers smaller than 4, like 3? No. What about 2? 2 minus 4 will give me a negative. 1 minus 4 will give me a negative. 0 minus 4 will give me a negative. Negative 1 minus 4 give me a negative, or negative 5. So I need to put numbers in that are not less than or equal to. I just said a bunch of numbers less than. If I say 4, a number less than 4 is 3. We just said we can't plug 3 in. Right? And so I have to have numbers that are bigger than 4 or what? They can also be equal to 4, right? Yeah. So what I'm saying in my domain is I'm saying my x value must be bigger than or equal to what? 4. There's your domain right there. My x value must be bigger than or equal to 4. Now let's say we wanted to put that in interval notation. What's our starting point? 4. Does that go in a bracket or parentheses? A bracket because it's included, because you can see right here this is equal to. And then it goes all the way. Is it going right or left? Right. Look at my inequality. Which way is that arrow pointing? Right. This arrow is pointing right here. So it's to positive infinity, right? So x is greater than or equal to 4 means the same thing as 4 to infinity, right? And so what I'm saying is any number from 4 to infinity, if I plug it in, I'll get an output. But any number smaller than 4, I won't get an output, will I? So let's look at this one. This is our last one. I want to know what the domain is, right? And so I can't have a negative under this radical right here, can I? So what is a number that I could put in for x that would give me problems? Let's say I plug negative 3 in. Okay? If I plug negative 3 in, I'd have the square root of 2 plus negative 3, which is the square root of negative 1, right? Well, I can't do that, can I? Now, what's the number that when I plug it in will give me 0? Right, so if I say the square root of 2 plus negative 2, that gives me 0, right? So when I'm dealing with square roots, my starting point will always be whatever will give me 0. So now, does my x need to be smaller than negative 2 or bigger than negative 2? Well, let's test it. Give me a number smaller than negative 2. Negative 3. So let's do the square root of 2 plus negative 3. That's the square root of negative 1, isn't it? Well, I can't do that, can I? So let's try a number bigger than negative 2. What about, is 0 bigger than negative 2? Yes. So let's do that. The square root of 2 plus 0 is the square root of 2. And in my calculator, I can type in square root of 2 and get an output, right? Yeah. Okay. So I know that my x value must be bigger than or equal to what? 2. Not 2. So I'm going to say my x must be bigger than or equal to negative 2. So that right there is your domain. Say domain. Domain. So just to review, what are the only 2 things that cause restrictions in algebra? Dividing by 0 and a negative under the what? Square root or any even root. If it's 4th root or 6th root.